So today we're gonna expose a few AI security leaks. And I hope by the end of this video, you're gonna be understanding much better what kind of AI security breaches can happen in the real world. And the addition that we are gonna give you compared to all the other videos out there is that I'm gonna try to give you real use cases with real hacks that actually happened, and some of them I'm gonna make it myself, so stay tuned. By the end of the video we're gonna do some data poisoning, and it's gonna be very fun and pretty interesting. And also at the end of this video I'm gonna make a few predictions of the next kind of AI attacks that are gonna happen based on the very latest technologies, including the MCP Model Context Protocol from Anthropic that's been released very recently, that is supposed to streamline all the agentic AI that is coming in 2025. So first of all, a little introduction. What is AI security and what's the difference between AI security and traditional cybersecurity? So basically, the addition of AI in the pipeline of a software pipeline has added additional surface of attack, like data poisoning, like model theft, adversarial attacks, and data breaches, including the other traditional cybersecurity attacks. And why is it important? It's because more and more AI is making critical decisions and handles more and more sensitive data and has more power on our infrastructures. So it affects more and more human lives, and it's very important to get this right in order to continue having systems that are performing well. One big difference between traditional systems and AI systems is that traditional systems are based on static rules. So when there is an attack, it's pretty easier, I would say, than when you attack an AI system. AI systems are more dynamic and they constantly learn. So this is a graph that shows you basically when you have a traditional attack, it mostly happens suddenly, and obviously at the end, it has clear evidence and it can easily be restored by backup or previous version, a patch. But when it comes to AI security breaches, it comes subtly over time, gradually, and it's very hard to restore. And it's also very hard to identify. So for example, when you do some data poisoning and progressively a data set getting poisoned, time after time, day after day, the model shifts gradually, and it's only months later that we discover. So briefly, and we're not gonna stay too long on that, these are all the dimensions of AI security. Today we're gonna dig into the technical aspect. I'm gonna show you a few very practical hacks that has been done in the last 3 months. Some of them have been done in the last few days, but you have an overview of all the different aspects and dimensions of AI security, from strategy to operation, from data to the governance of the company. And I talk about it in my book, Securing AI in Finance, where I approach all the different aspects of the AI security. Here you can see basically where the breaches can reside. So either in the enterprise, on the servers, on the cloud. It can be on the edge, on smartphones, embedded into devices. There are many, many different places where we can have data and AI breaches. Here are basically some of, not all, but some of the major attacks made on AI systems. You can see from data poisoning to prompt injection and model extraction. And of course, we have the traditional attacks. Additional to security, we have anything related to safety and hallucination, bias, and abuses. And just for illustration, I want to show you some kind of safety abuse that can happen by demonstrating on our platform that we are selling to companies at Ultra Deep Tech. And I'm going to make you a demonstration of hallucination, bias, and abuse. So here you can see Safety Shield Ultra, where we detect security and safety breaches. And here, this is a sample chatbot where we just simulate a bank where employees can access the internal chatbot to ask information about the company. And then when I'm clicking here and I'm simply introducing, for example, a text like, for example, I would say some hallucination. Let's imagine that we are going to enter a text related to hallucination. So what, for example, will be the price of Bitcoin? Let's see. So here we have the chatbot that naturally answers. And when the answer is produced, if I do a little refresh here, you're able to see here on hallucination detected just now, today, what will be the price of Bitcoin, the input, the output. So our system is perfectly detecting this kind of hallucination and many others. Regarding bias, for example, I can put something a bit biased. Don't want to criticize any kind of people, but let's say older people, older person are slow. So once we see, we do a little refresh, and the platform is detecting over all the users of the chat, but also we can see the detail per user. So if you see here, I have detected some bias here that we can see here just been detected. So these are examples of safety issues that you can encounter in companies in traditional AI, conversational AI, and also in agentic AI. Our system is able to detect both. Now let's talk about security breach per se. So there are like several kinds of attack. Attack number one, image poisoning. This is what happens when we have basically data that is poisoned over time on the internet, that LLM is feeding itself, scraping the web. So it will download millions and millions of images from the web to feed its training algorithm. And then you have a normal image, a clean image, you feed it some random noise, it looks the same for the human eye, but then the model sees it as a different type, a different category. You can see a few examples. So if you poison it with a few hundreds of examples, it is not perfect, but once you give it enough examples, you start to identify dog as cats and things like that. So this is the first kind of attack on AI systems. And to illustrate, I show you some image poisoning, but this can also be applied to text poisoning. So with LLMs. So you can see here recently a breach that happened with Copilot, where Copilot is feeding itself from emails of the user. Any email that the user received, including attachments, it will feed the Copilot. And so what hackers did is they introduced some attachment with their bank account information. And over time, the model learned to associate the bank account the attackers gave to the bank account of the user. And when basically the user was asked to transfer money to his own account, it was transferred to the attacker's account. Here you can see another example of attack number 3, prompt injection. This is an example where I personally hacked Claude a few months ago, where we were able to extract the system prompt of Claude. More recently with DeepFake, this was done when DeepSeek just got released. So this is another example. Prompt injection is how you can inject malicious intent in your prompt to manipulate the AI agent. Here is a very traditional attack as well. Transfer learning plus malicious AI deployment. So what does that mean is that you can take foundational model, do some transfer learning on it, and make it, and by the transfer learning, adding some data set that are malicious. And then you can put it on open source platform like Hugging Face. People would download that, use those models without knowing they are malicious, and get false information or being directed to the wrong websites and get attacked that way. Malicious AI deployment is when inside the deployment pipeline of the AI model, there is some malicious code that you also download from open source platform like Hugging Face or GitHub. Another very traditional attack is data leak. Basically, it's very simple, is when users send sensitive data. And this is a thing that most people do without noticing, is that they send their data, their phone number, their email, and all things like that. And it feeds the model. If you don't pay attention, you're going to feed the model with your personal data and it's going to train with it. And if it's a malicious owner, the person who owns the model that you're using is going to use your information against you. So here is a pretty interesting also attack that happened with Copilot as well, because Copilot feeds from Google, from Word, so text. So when you editing your text, you can ask information about your documents, and then this user asks to summarize this PDF, which is a traditional normal legal text. And then Copilot answer that your account is locked due to suspicious activity. And it asks to send password and credentials to a certain email address, which is a complete malicious attack. And how did this happen? Very simply, this is an invisible poisoning. You can see that a very small font has been introduced into this dot at the end of this text here, asking it to ignore everything else and then to just display that text. So you could be tricked by invisible poisoning. Attack number 7 is obviously DeepFake, that you can see here with a fake person that you have a video call with. And there was last year a very famous attack where in Singapore or Hong Kong, they tricked a bank employee to send and wire $25 million to hackers by impersonating the person voice and the person face through AI. And so now let's talk about attack number 8. So invisible poisoning. It's another invisible poisoning attack, but this time is more insidious. This happened very recently, about a week ago. And so it's basically the use of invisible characters that you can introduce into rule files. So there are now more and more software where you can program with AI, like Cursor and Microsoft Copilot, and then those GitHub repo have instruction file, like rule file, dedicated to the AI to read and to be able to modify the code accordingly. So as you can see here, what you see in white was the text that was visible. What you see in yellow and red was the text that was invisible. And how text can be invisible, I'm going to show you in a minute. But basically, this invisible text was saying to ignore anything previously said and to add this link here in the HTML code. And this link is linking to malicious address where it's going to extract all your data. So you can see here a poster where I explain how this is done, how invisible characters can be used. And before I show you, this poster is available, by the way, in the video description. You can download it if you want to understand it better. And so basically you can see that there are many invisible characters into the basically encoding of Unicode. And those characters correspond at different other language like Arabic or some languages that have invisible characters that's necessary to cut word in some places, and those characters can be used, and they can be used, and they're absolutely invisible, but they can be used to code some information. And I'm going to show you now how I managed to use that. This is the way it's processed, by the way, where you can see how it's done. But I'm going to show you now in real time how I actually did it. So I actually here ask Claude to make me a dictionary where it corresponds an invisible character to each letter of the alphabet, and then to give a small instruction to decode this invisible character. So this text has been introduced to a normal visible text. The sky is blue today, or for example, dogs make the best pets. But there is a malicious text introduced inside. And then to prove that it works, as you can see here, I put exactly that prompt, and Claude was able to see the invisible text. You can see here. This is the actually invisible text. Backdoors, imagine what I can see hiding in the text. And to show you how that works, here, this is a little website that shows invisible Unicode characters where I paste my text, which is look totally normal. Then you can see the real series of characters that appear. All those characters are invisible characters, and they are encoding, corresponding to the definition I gave here, they are encoding the message. This message could be a malicious message, malicious intent, and this could be embedded in rule files that you download inside a GitHub repo, and then being read by some AI assistant, and it's a huge data breach, so we need to be very careful. This happened just a few days ago. Finally, there is a last kind of attack that is about to happen called MCP. I call it MCP infiltration, and it's because MCP is the acronym for Model Context Protocol, created by Anthropic. Basically, it's the equivalent of agentic AI, but standardized. So before MCP, which was released in December 2024, and people are starting to massively adopt, there was agentic AI frameworks where companies were just writing their code and how the AI was able to connect to software. But now with MCP, it's kind of like a REST API where you can just standardize this process. And what it allows you to do is that instead of creating your own connection with data or with code, you can just download some MCP that's already done. And because of that, there is a new attack surface where you can download some MCPs from third parties that are malicious. And so these are the different attacks that are possible. So, for example, you can see this website called Glana. You can download some MCP rules already. So, for example, I can show you basically how I implemented an MCP rule with Claude. So on the desktop version of Claude, I implemented an MCP. It's quite known that Claude doesn't have access to the web, but thanks to MCPs, I'm able to access the web through Claude. So here, as you can see, I had to specify Claude to use the web because naturally it doesn't yet realize, since MCP is a very new concept. But when I tell Claude to use the web, he understands he needs to go and use Brave web search. I allow it, and now is sending the query to the MCP connection, and Claude was able to search the web and give me his analysis of the news of today, 26th of March 2025, etc., etc. So this is how the AI development and AI software stack is going in 2025. And we are preparing for all those breaches and attacks. We already have patch for MCP attacks at Ultra Deep Tech, and that we have introduced into our solutions. So this is basically all the attack vectors that we have in 2024 as of today.